Let us solve one problem by applying lamis theorem. Here is the object. The weight of the object is some 100 Newton. It is suspended with the help of two strings. This angle is 90 degrees and this is 53 degrees, 37 degrees, and the tension developed in this string is T2, in this string is T1. Now if it is in equilibrium, let us calculate T1 and T2. This angle is 90 degrees, so we have to know this angle, also this angle, so that we can apply lamis theorem, because three forces are present only. This angle 53 because it is 53, so this is 90 degrees, so 90 plus 53 degrees, and this is 37, this is also 37, so this total angle is 90 plus 37 degrees. Now let us apply the lamis theorem. This force by sine of opposite angle, sine 90 degrees, is equal to this tension T1 by sine of this sine 90 plus 53 is equal to this T2 by sine of this angle, opposite angle, sine 90 plus 37. So 100 by sine 90 is 1. So T1 by, it is in second quadrant, 90. So sine will be cos 53 is equal to T2 by cos 37. And these values we can read from this right angle triangle. This is 37 degrees, this will be 53. So 3, 4, 5, cos 37. For 37, 4 is adjacent. So T1 by 4 by 5 is equal to T2 53. For 53, 3 is adjacent, so 3 by 5. For 37, 4 is adjacent, so 4 by 5, that is equal to 100. So these two are equal and these two are also equal. 100 is equal to 5 T1 by 3. So 300 by 5, that is T1 is equal to 60 Newton, and 100 is equal to 5 T2 by 4. So 400 by 5, T2 is equal to 80 Newton. I am going to introduce another method, and this particular method is useful whenever there are more than 3 forces also, or 5 forces or 6 forces, whatever that may be. But this lamis theorem is only correct when the object is under the application of 3 forces and it is in equilibrium. And now whatever be the method that I am going to introduce is correct when the object is under the application of more than 3 forces and is in equilibrium position. In this method I am going to resolve the forces into components. Here it is 100 Newton and this is T2, this angle is 53. So this T2 I am resolving into components, T2 cos 53 and this is T2 sin 53. So in upward direction I am writing T2 sin 53. So you can forget about the T2 after resolving this vector into components. Next, this is T1 here. So this angle is 37 and this is T1 cos 37 adjacent, this is opposite. So T1 sin 37. In upward direction I am taking, you can forget about this. It is under equilibrium position. So left force is equal to right force, upward force is equal to downward force. So then only this object is in equilibrium position. That is T1 cos 37 is equal to T2 cos 53 is one condition. And another condition is upward forces is equal to downward forces. So T2 sin 53 plus T1 sin 37 is equal to 100. And we are having two equations. So solve for two variables T1 and T2, that's all. So T1 cos 37 is 4 by 5. T2 cos 53 is 3 by 5. So 5 cancel, so T2 is equal to 4 by 3 T1. That is substituted in this equation. So T2 is 4 by 3 T1 and sin 53 is 4 by 5 plus T1 sin 37 is 3 by 5 is equal to 100. So 16 T1 by 15 plus you can take 3 and 3 T1 is equal to 500. Now 16 T1 plus 9 T1 is equal to 1500. So 25 T1 is equal to 1500. So what you are going to get? T1 is equal to 60 Newton. Next, because 25 6 is 150 and 0. Next T2 value. Here is T2. T2 is equal to 4 by 3 into T1. T1 is 60. So that is equal to 80 newtons. Of course, as far as this particular problem is concerned, I may take more number of steps for this method, but this is very useful in every case. But it is useful only it is under the application of three forces, very important one, and still the body is in equilibrium position.